Examples of integration and avoiding traps. That's the lesson for today. We have 4 examples to go through, and let's start with the first one. And as you are doing this, you need to pause at one point and make sure you are following my explanation and understanding the concept, okay? All right, first one, I'm going to start it with a hard one. This is the one that you have to be very careful. Well, let's go ahead and just do the integration, but before doing that, make sure that you're using the power law. So we're going to rewrite this as a power, x to the negative 2 dx. So that would be x to the negative 2 plus 1 divided by negative 2 plus 1. And then we're going to evaluate that from negative 1 to 3. And when you do the math, you get negative 1/3, negative 1, which your final answer will end up being negative 4/3. Okay. Now, if you leave it be like this, then you have made an error, a huge error. You've gone against the fundamental theorem of calculus. The very first thing that you realize that this function, so f of x, which is 1 over x squared, this is greater than 0, not equal to 0, is greater than 0 for all values of x, and therefore this integrand or integration must be greater than 0. That's one of the properties. The fundamental theorem of calculus only applies to the continuous function. This is not continuous within the interval of negative 1 to 3. Okay, so not continuous in this interval. And because of that, this answer, it doesn't work. So therefore, this integration doesn't have a solution. Okay, so very important. Make sure you go back and make sure you remember the function is not continuous, therefore the integration cannot happen. All right, let's look at the next one. So this was the first trap, so make sure. Okay, let's look at the second one. We want to do the integration of 1 over t squared minus 1 over t to the 4th dt. So I changed the function to the f of t, not a big deal. So we're just going to go ahead and then again break it up and then come back. So that's the first step. We have to break it up, and then we're going to go ahead and then do the integration for each function separately. So this would to the negative 1, negative in front, and then we're going to evaluate that between 1 and 3 minus, and the other one will be your adding, so that would be negative 3 in the bottom, t to the negative 3, and then we're going to evaluate that between 1 and 3. Okay, that's what we're going to get. And then we're going to go ahead and simplify each one, and let's go ahead and do that. And you do the math, you get the first part negative 1/3 negative 1 minus, and then inside in the second term t to the negative 3, you start with the upper bound 3, you plug it in, and when you do the math, there's a negative 3 in the bottom, so I do have to include that negative 3 here somewhere. Here we go, that's the negative 3, and then the other part is 1/3, because 1 to the negative 3 is still 1, and there's negative 1/3 down here. Now, there is a negative in here too, so this is a little bit tricky one. You have to pay attention to the negative and positive, because that's what you have to do. And now we're going to go ahead and simplify. So this one is tricky. Make sure you realize that there's a negative here and there's a negative there, and then you have this negative down here. All right, so first part, negative 1/3 minus 1, so that's negative 4/3. You're just adding the two fractions, plus, so negative times a negative is negative 1 times a negative 1 as positive, so that would be 1 over 3 to the 4th. And then this negative has to be multiplied inside, but before doing that, this negative and this negative, which is negative 1/3, that is positives, and the negative comes in, and then this value is negative right there. That's negative. And then when you do the math, you get negative 5/3 plus 1 over 81, which the final answer will be negative 134 over 81. Okay, so that's the second question. Let's do the third one now. Okay, let's do the third one. Here it is. So we're going to go ahead again and change that to the power first, and then we're going to go ahead and solve. So changing it to the exponential form first, this is 2 to 4, and this would be 2x to the power of, and in this case will be 1/3, because that's how you change the radical to the exponential, dx. Okay, and now we're going to go ahead and do the math on that. So the 2 outside, and x would be x plus, you're going to add 1 to it, so that would be 4/3, and then divided by 4/3, okay? And then we're going to evaluate that from 2 to 4. Very good. Now, it looks ugly, but don't worry, don't panic. We're going to do the math. All right, first thing. So the first thing is that when you have a fraction in the bottom, you can just flip that and bring it over. So that would be 6/4 x to the 4/3. Okay, so another way of doing that is that if you have 1/4 that's equal to 3/4. Okay, and this 3/4, well, there's a 2 in here. So 2 times 3, that's 6. And then you got 4 on the bottom. We're going to simplify that. It would be 3/2 x to the 4/3. And then we're going to deal with that from 2 to 4. Okay, let's do that. And you get this value. And then if we change it to the radical, back to the radical, we have 3 here. We have 4 to the 4th inside minus another 3/2. And then we have the cube root of 2 to the 4th. Now we can go ahead and simplify more. And what we will get is 3/2 times 4 cube root of 4, because 4 cubed is a factor, we can take that out. And then the next one, 3/2, and then times 2, and that's cube root of 2. And then the final answer for that one will end up being 6 cube root of 4 minus 3 cube root of 2. They're not like terms. We can't really do anything, and we have to take out our calculator and take the approximation, and I'm going to leave that with you. Okay, and that's the answer to the last question, number 3. Okay, very nice. Let's look at another one, and the last one, and this is the little bit more involved. So let's go ahead and first change everything to the exponent form. So here it is, and the way you do that, the radical comes up, and that becomes -1/2, and that's dx. Great. So this is actually very easy. It looks ugly, but it's actually quite easy. I'm just going to multiply these two terms. We're going to multiply x to the -1/2 into the bracket. Okay, so that's what we're going to do. So let's go ahead and do that. Integration of that. So x to the -1/2 times x squared, you're adding the exponent. So this would be x to the 3/2, and then plus x to the -1/2, and both in the bracket dx. We're going to do the integration of that. Now that's easy. We're going to break it up and then go ahead from there. So first we're going to take the integration of the first term plus the second term. Very, very simple. And when you do this, you'll get the final answer. So let's go ahead and do that. And you simply do the antiderivative formula. You add 1 and then flip that over. You do the same thing to the other one, and then we're going to now polish that and then go from there. So x to the 3/2 plus 1, that's 5/2. So x to the 5/2. And then the bottom is 5/2, so you can just flip that, and that becomes 2/5. Remember in the last example, I explained the denominator being fraction, how you would do that. So make sure you go back and double check. We do the same thing with the other one, and that becomes x to the 1/2. You multiply by 2. And check out the interval between 1 and 2. And the final step is the direct substitution, upper bound first, subtract away from this lower bound, so as the second term, and then put them all together. When you go ahead and plug in the numbers for the upper bound and lower bound, and you do the second term, you're going to get this value right there. It looks ugly, but that's okay. You just go ahead and polish that with the math. Just a reminder that 2 to the 7 divided by 2 is the square root of 2 to the 7. We don't put the 2 in there, but I put it in there just that you see the denominator is the index of the radical. And then you go ahead and simplify. But I'm going to leave this last part with you. So this is 2 to the 3rd root 2 is this right there, right? So that is that, and then we have to go ahead and simplify, and that's just too easy in this case. Okay, so final answer will be, here it is. After doing all the mathematical gymnastics, you're going to get this 18 root 2 minus 12 over 5. I think I did this all right, but there's a little bit of algebra involved, and that's basically it. All right, until next time, check out the next video in the series, integration through substitution. All right, until next time.